Now the second question requires you to study figure 6.1. Figure 6.1 is a typical line graph, or rather it's an atypical line graph. When you look at it very carefully, the intersection points are not actually marked out. It actually is a graph that shows the reported deaths from the aforementioned Sichuan earthquake, right? So if you're looking at this, the question actually asks you to suggest why the number of people reported dead change. So that you do need to recognize that you must talk about change in the very first place. Okay, throughout the period of time that's shown, which is from the 12th of May all the way until past the 30th of May, actually it's tracked. So they are looking at the amount of people who were reported dead. So one more thing to look at, if you look at the number here, this is actually on an increasing trend. You should be able to see that. Okay, but there is a change in gradient, so it's increasing at a very steep pace. But after the 26th of May, you can visibly see that the gradient has reduced by quite a bit, and that's a result of the number of deaths falling, okay, or not increasing at as significant rate. So for the 3-mark question, what are we looking for? Then largely, always remember that you need, whatever you're quoting, you need data to support. Okay, you see the significant change in gradient first, right? So whenever you're looking at something like this, there should be a change in gradient. It cannot be 3 mark for a very consistent gradient with no anomalies at all. So they will definitely give you some form of a change that it will require you to pick out. Okay, so why do you believe, okay, that there will be a change in this number then, right? So you look at it within the first week itself. Why is it that you have so high a rate, right? Then why would it decrease after the first week? Bear in mind, this is an earthquake. So how do people die in an earthquake? Okay, how does death post-earthquake occur? At the moment of the earthquake, of course, we will have a lot of people dying. Now, why is it that it's not straight away jumping to like 80,000, 90,000 from the very beginning? Of course, it's got to do with reporting, sorting out, finding the corpses, finding the survivors, and at the end of the day, after the first week, what happens? Okay, now, will you continue to find a large amount of deaths after this? I don't think it's possible. So if you're not going to look at having a large amount of deaths constantly being churned out, you will see a slight decrease. Therefore, it could then be the accounting for what happens after the 26th of May. Why is it that the increase seems to be at a slower rate then? Okay, bear in mind, data support is very important. This is ultimately data response question, so you must have data support. If you don't have data support, you will not be able to secure full marks. Okay, data response questions, right? Given the nature of the testing, it requires data support. If you don't have data support, you're not going to pass. You may get 1 or 2 marks if it's a 5-mark question, but you will not pass. So keep that in mind, that's important. As we move on to the next question. So this is another type of stimulus that you may see. This is a map, right? A map. So what you will have in this case here, if you look at the legend, is earthquakes, locations, right? Numbered locations, and the magnitude of the earthquake. Of course, the more important one that you may miss out is the word plate boundary here. So the dotted line around shows where the plate boundary is. So there's actually a final piece of information that is you can harness if you are a bit more careful and you look at the map in more detail. It is the scale. So there's actually a scale given in the map, which means that you can use your ruler and you can measure and give me data related to the scale. Okay. So what are we supposed to look at then when you're describing relationship between magnitude and distance from the plate boundary? You do need to measure distance. You need to tell me, is it your belief that is high, is it low, and then what does the data actually support? So look for examples of these 4 key things to list in your answer. Near boundary, high magnitude. Okay, what will satisfy this? Would your high magnitude, would your 1, 2, 3 be near boundaries? There are 2. Okay, location 2, Arunachal Pradesh China border, right? It's right on the boundary itself of the Eurasian plate, and it's a rather high 8.5 magnitude, right? So similarly, you look for one that's near but low magnitude, one that's far but high magnitude, and one that's far low magnitude. Okay, so these are the different types of relationships that you can have at plate boundaries and between the magnitude and the distance from plate boundary. Okay, so once again, I want to remind you for this one is more in the case of whether you support your listed item. So if you're going to tell me, like for example, location 12, Koina is 6.5. What's the distance from the nearest plate boundary? Is it more than 1,000 kilometers? Right, I think it's about 1,002 to 1,005 kilometers from the Iranian plate boundary itself. So these are important data support that you must remember, you must put down. Okay, so a question like this is what we are dealing with. Right, your map, once again, you should be getting one in color with the printings clear enough for you to look at. The one in your text, in your handout, is rather clear actually. So next one here is right, this is your occurrences of large cities and earthquakes which have occurred. So they're mapping the earthquakes in the black circles and the cities as the white circles. So you can actually see there are some cities that are really along the earthquake belt, earthquake boundary. There are some cities that are actually not on the earthquake boundary. They're on the opposite coast, or they're found further inland away from these boundaries. Okay, so what then the question asking for? They're asking for similarities and differences in the location of large cities and earthquakes. So you will need to tell the examiner, in this case, there are two distinct patterns. One, where your large cities are actually not near the earthquakes. Right? Where are some of these locations? What is your evidence? Okay, which continent? Right? If you are able to quote the city, well and good, but in this case here, you are required to know the continent, so this is baseline information that you must be able to provide to us. Okay, so for example, I can talk about the eastern coast of North America and South America. You will have cities along the eastern coast that are not near your earthquake zones. However, on the western coast, you will have all your cities, North and South America, that are along the earthquake zones. So this is important, right? So what are we looking for? We're looking at your ability to pick out whether there are relationships like this: large cities near the earthquakes, large cities away from the earthquake. Which continent are we talking about? At least, if not the city itself. Are there any special places where earthquake areas without cities? Okay, why? Why are these areas special? Okay, what I'm looking at in particular is actually serving to highlight the point that you are aware that your earthquakes did not occur only on land. So if you look at the Mid-Atlantic Ridge zone, right, there's a whole line of where earthquakes occur, but there is actually no city. Reasoning behind that is the Mid-Atlantic Ridge, so you should be able to tell me what's the reasoning behind it. Okay, so keep this in mind. This is what we will be looking at in terms of a distribution map like this that doesn't ask for a description of the spread. They ask for a description of certain relationships between the factors that are listed on the map. This is highly unusual. We normally don't see things like this. Normally we see map questions with describe that require you to describe the distribution. Then you need to give me an overall trend. You need to give me a general description of movement, right? A flow. But this isn't that kind of a question. So I think this warrants some time. Take some time, look at this. Think about what you're going to do. How are you going to approach a question like this? Okay, now coming to the fifth one. Okay, so in this particular one here, 13.1, this is actually two slope profiles that have been drawn before and after the landslide. So before is the solid black line. You can see that there are two very steep cliff face. One at about between 750 to about 2,500 meters, okay, towards the east, and another one further down. Okay, so I've segmented this up into 4 clear sections to do the discussion upon. So you need to have 4 clear sections. In this case, the sections actually show big change pre and post. Of course, the first section doesn't. Bear in mind, first section actually shows that there's no change in the shape and height of the land for the very initial part nearest to the west. So these are things you need to talk about. I give an example for the second portion that we've highlighted here. So if you take a look with me here, pre-earthquake, pre-landslide, the drop is a rather steep gradient, right, falling downwards. Okay, but after the landslide, the gradient has become even worse. The gradient is even steeper now after the impact of the landslide. So more of the soil has really slid down to the lower part of the hill, and as a result, you are having a more severe shape. Okay, so you need to do for 2, for 3, for 4, and of course you start with 1, which is stayed about the same for the first section here. So for a question like this, all 4 sections need to be highlighted with data, right? Description will be your data, right? If you're able to give me the height in terms of meters and where you can find this section that you're talking about, that would be even better. Next, this is a scatter plot graph. Right, scatter plot graph, but it is not a very dramatic one like the ones that we did earlier on. Okay, so for your other weather and climate components, this is actually a scatter plot graph that is used for number of landslides and magnitude of earthquakes. So you're going to find the relationship once again. So key point to note, whenever you're looking at relationship, right? Relationship, we are always looking at scatter plot graphs. Okay, that's the only graph that can show relationship. You are always looking either is a positive relationship, meaning you increase in one axis, you will have an increase in the other axis as well, or negative relationship, which means that you increase in one axis, you have a decrease in the other axis. So if you look at this particular one here, the relationship is actually positive, because as I move up from magnitude 5 to 7, you will see that the number of landslides actually increase. The dots do go up. Okay, so of course, when you're talking about relationships and this kind of thing, right, you do need to mention a couple of data support points. So you need to mention at magnitude 5, okay, 5, so you approach towards 6, it's generally no landslides. However, once you breach the point of 6, right, some landslides tend to occur. If you breach 7, okay, as you approach 8, you will have a lot more landslides occurring. Okay, so always bear in mind relationship. Okay, what does the relationship show? And finally, what's the data to support this? Second last one. Now, this one is very simple, but this one is a twist on our normal tectonic plate boundary map. So this is a very small area of the Philippine plate and the Sunda plate, where actually it doesn't compress against one another directly. So at this point here, where you have X and Y, right, it's actually a transform plate boundary. So the question actually asks, your worksheet has the question, my image here doesn't. Right, the question actually asks for what is the type of movement and why is it at XY boundary, right, you do experience earthquakes. So first and foremost, you need to identify what kind of boundary this is. And if you look very carefully at the key, right, the key actually tells you the boundary itself. What happens at this boundary? What are the key processes at this point? Recall. If you cannot recall, go into your notes, go into your textbooks, dig the information out and take a look. Okay. Finally, link to earthquakes. Link to earthquakes. What does that transform boundary? How does it link to earthquakes itself? What are the key terms we're looking at? Things like friction. Okay, buckling. Okay, holding in place, snapping forward, buckling, releasing tremors. These are all the general keywords that you will need to describe an earthquake. And these all need to come out in your answer. So, a very simple graph, right? Finally, infographics. Infographics, this is the final type that we will be looking at for today. Right, tsunami-proof home. This is an infographic features of a tsunami-proof home along a coast. Right, so if you look very carefully, there are five features that mitigate the impact. Okay, the 6th item that's on this, right, is actually the predicted maximum surge to show you that actually the whole building is above the maximum storm surge, so that if a tsunami, predicted tsunami size comes along, it should not be hit. Okay. Now, what they want you to do is explain how the features can mitigate the impact of tsunami. There are 5 features, so you need to deal with them individually. Start with one and end with the last one. Okay, move in sequence. Please don't jump around. It's very, very chaotic for you when you're checking. Okay, it doesn't really matter for the marker, but bear in mind you need to have time to check. Okay, so it's very chaotic when you're jumping around. Your lack of time already, you want to have something easy to check on. Okay, so I would normally start either with the bottom or the top, either with evacuation tower of up to 10 meters high. What would the evacuation tower do? What does it do for such a situation? Why do you need it to be 10 meters high? Okay, because that's generally taken to be the moment where it's still possible to do some intervention. Okay, the second one, wooden shutters on windows, no glass. Why is it that you shouldn't have glass? In times of tsunami, what will happen to the glass if the tsunami were to hit? So this is important. Then also talk about the reinforced foundations. How does that help hold your building in place? Okay, the idea of flexibility is important because your stilt bases, if they are flexible, they will be able to flex and not break. Now, if you are able to look at the larger context of tsunamis, when it doesn't break, the rate of survival will be a lot higher. So not only are you able to be above the water at the 10 meter high tower, the risk of getting hurt by broken windows with no glass is lowered. The flexible stilt bases enhance your survival chance. Okay, finally you look at the wide and angled stilts. Why wide and angled? Think of what kind of a center of gravity would this encourage, and how does center of gravity actually work in this case here. So 5 pieces of information, 5 features. You need to identify each of them and explain their function in this case here. Right, so in total we have covered infographics today, maps, scatter plot graph. This is a profile, a hill profile, or not really a line graph, hill profile. Okay, large scale distribution map, detailed distribution map. Okay, and then one more, we started off with another line graph and then a photograph here. So these are your common stimulus that you will see with the living with tectonic hazards topic. So similar to the previous CSC, I will need you to pick two that you're most uncomfortable with, preferably, right? Think about it in detail, craft the answer, and you send me the answer through Teams. Okay? Please complete the first assignment and this assignment preferably before I see you the next time, which is in, I think, 2 weeks time. Okay, so go and get this done. You can use the rest of the time, or you can sneak some time within the week itself. It's just 2 questions, right? It shouldn't take you too much time to do this. Okay, thank you ladies, and I'll see you at the next CSC.